attendance together. As soon as we have 4 people in the room, I'm going to say split into pairs and start doing the problem on the board. Dun, dun, dun.
We have 3 people.
I know. As soon as one more person walks in the room.
Nathan.
Nick, we're gonna cook this up, right?
Yeah. How do you do this?
I don't know, but we're figuring it out. I think we did like the one maybe further back. Maybe.
What? Why is everybody late? This is amazingly late.
Oh yeah, we did a practice one.
Hello. Okay. You came in when the bell rang. So, after this point, everybody's late. So, let's see. Etienne, Lavina, Chio, Josh, Samuel, Ella, Sonia, Andrew, Nathan, Katie, Nicholas, Ted, Gleb,
This is just like one of the.
Neha.
They're at the door, Mr. Phillips.
Taz and Ashley, you're up. Start doing the problem on the board. You're now paired.
Sure. So
Yeah,
it's
just do EJ plus.
well, which one's
Skill testing questions.
H plus A? Mr. Newfeld, there's someone up there.
Oh, I know.
Or a lot of someone.
There's a lot of someones. There's a lot of people who are late.
Yes.
So I need some sample exam questions.
Next. Okay, so that would be 0.
Correct chemical formula for aluminum nitrate.
ALNO3.
No. No. Next. Correct formula for aluminum nitrate.
Do you do this?
Same thing.
No.
Yeah.
I just said no.
L. NO4.
No. No.
AL2 NO3.
NO3, so NO3 is in brackets, and then another 3.
Excellent.
That one. You got Google that.
Wait, but other people go.
Oh, I know. I know. I just need to get another question. Actually, I should just do naming questions.
No.
Is it acid? Is it
Iron 2 oxide.
one or is it?
Because yeah, but they do this.
Iron 2 oxide.
FNO3.
There you go. Once you have a pair, start working on the problem. Iron 3 oxide.
Okay, do I put this one?
Maybe 203.
Give me that.
Ooh. Aluminum chromate.
Okay, so
AL3.
So about the A.
So hold it. What is the charger chromate?
0. Don't forget
AL2CR3O12. Thank you.
Nope. Oh,
What?
12? What are you talking about?
Aluminum CR3O12.
What? Are you using this? Wait, okay, you're on the right track, but that is crazy. No. What? AL3.
We just keep answering wrong questions.
AL2CR3.
There you go. Polyatomic ion, so you gotta have it in brackets. Okay, this will be a speed one. Sodium chloride. I think I heard your voice first. Once you have a partner, still working on the problem board. Let's see. Copper 2 chloride.
I'll tell you guys.
Copper 3 chloride. copper.
Would this be plus?
Yes.
I said that first!
I couldn't tell.
So mean.
You kept changing it. I got confused. Potassium chloride. Lithium chloride. It's not alkali metal, it's only +1.
What would it be?
There you go. Why were so many of you late?
We were 3 seconds late.
It's a break. We're in a break. Give all break to get here in time.
I was
There's
in
no
bed.
excuse.
I was asleep.
Anyway, start working on the problem on the board in pairs. Find a pair. Once you have it, call me over. Check with others. I just finished doing attendance. Etienne arrived. Lavina arrived. Teo's here. Josh is here. Is Samuel in here? I didn't see Samuel. Okay, Ella, Sonia, Andrew. Katie's not here today, right?
No, she's coming.
No, she emailed me to say she would not be. Well, maybe that's Katie Watt. Never mind. Other class. Is Katie? Katie's not in here right now.
Katie was outside. What is solid?
Where did she go?
She just went to the bathroom and she said she's coming back.
Yeah.
Oh. Gleb is here. No, what are you doing? Yeah, you can't let them in. They have to pass.
class.
They have to pass a skill testing question.
Yeah.
I don't have skills right now.
Calcium oxide. What's the formula?
It's like we don't have anything.
We don't have anything.
Yeah. So would it just be H and A?
Not,
How is S?
CA. No.
That's how you say it. Calcium oxide.
CAO.
CAO. Excellent.
Thank you.
Find a pair. You're intermediate pairs. There seems to be a group of 4 at the back. Split up.
I'm just walking.
Split. So we got JK, Neha. Max is here.
What's the age again?
There. I like it when they look in like sad people who can't have a treat.
Would you put that in here?
Chemistry teachers don't reproduce, we just divide.
What is solid? Solid.
Solution, yes, so 0.1 molar solution. You're gonna find the Ka.
Cancel out X.
And how many people have written it? You've written the formula, you've written the chemical formula, you've written the chemical formula.
X.
Don't forget your charges, even if it's fake. Is that a 10? Charges in your chemical formula? I just want everybody in the habit of doing that. Aha! Iron 2 oxide, what's the formula?
And then I think we just.
What are we trying to find? I'm on my first lead.
Wait, I
Right, so,
Do you do negative log?
Don't we like?
oh, yeah, you need to know
Oh,
that.
it's 10 to the pH.
Depends on what kind of pH.
10 to negative pH.
What do?
I think I messed up.
I think I messed up.
It's like, I don't know, you have to.
Well, the question I ask is, there's a value on the board you haven't used.
X squared.
We haven't used pH either.
Yeah, actually, a lot of these seem to be doing it. You're doing the exam the same as last day, but you actually have an extra piece of information. Last day you had the Ka. Today you don't. You're finding it. But you do have the pH. Yesterday you were asked to calculate the pH. Where does the pH go?
Wait, but how do we
Okay, I
put pH
definitely
into
multiply
pH?
Where's the pH go?
Concentration of
Let me guess, I lost it.
Where does pH go?
Yeah, that's a good question. What kind of value is it? Is it an initial change equilibrium? What kind of value is it?
It's an answer.
Yeah.
Like, can't you change it into? It doesn't change. You can't put it change, can
Oh,
it?
well, I guess this is 0.1.
So we did this question last day.
Yeah.
Which would add up to.
No, we didn't quite finish it, but
Yeah, exactly.
but where were we calculating the pH from?
The change? Can't you change the concentration? It's the only values we don't have.
Right. So if you measure the pH, what value is that? Is it the initial before anything happens? Beaker sitting on the table and you walk up and test the pH.
Yes, before.
Which value is that?
Initial.
No, not 10.
Sitting on the table, just hanging out.
Yeah, if it's just.
Lots of time has happened.
Oh, change. Oh, it's equilibrium.
So would that be K?
Oh, that's so what do I do then? You walk up and make it.
So in your table, where would that go?
I don't know.
Ah, you have formulas from last day. Lots and lots of formulas. I think everybody's up to there.
I know what class you're looking at, so I don't have to.
Oh, because
Why do you have approximately equal signs? Don't ever use it. Keep numbers. Keep them.
What's that button?
Keep them.
That's the equilibrium here.
I don't know if they're right or not, but
What does
whatever.
SOL-N mean?
Solution.
199.
Solution. Sorry, that's one of my shorthands from university. You know how many times in chemistry you have to write the word solution?
That works. Yeah.
okay, and then we just say no.
So now when you say 0.01995,
Oh, right there.
There you're like
Minus this.
No, it's okay. That's just.
the concentration is 0.0.
Chill.
Oh, that's so smart.
We got that.
oh, you have like one sig fig on it. So it's not 0.02. What is that? And you can always carry extra decimal.
995.
So not point. So 10 to the minus 1.70. And what did you get?
995.
0.
0.9.
Just trust me.
And you rounded that to 2? You must have had a 1 in front of that. 1995.
1995.
Yeah.
Wait, am I wrong?
Did you square root it already?
That makes sense.
Yeah, but you have to solve for like.
Now start filling things in.
Yeah, 0.0199.
Yeah.
Oh, okay.
And then you put it into your table.
We did that.
Wait, Noof, where do you get that? Where do you get this? 0.99. Why is it 10 to the negative of the pH?
Oh, that's how you solve for.
That's just how you calculate it.
That's how you solve for.
Like-
Alright. Oh.
It's one of the formulas. 1.70 is 2 sig figs. Because it's a pH.
So we did too many sig figs?
You can't do just too many until the very, very end.
So you want to do as many?
Yeah, many as you can until the very, very end. And I find 0.01995 is irritating as well. Because you have to make it 0.202000. But
We did.
well, you cut off all the zeros.
Okay, well, what if we were up to 0?
Then you would be technically correct.
Then we'll do that.
Yeah, you do that.
11. Oh, went up to 205. Got down to 165.
Well, what is the answer, by the way?
Yeah, that was
Hold it. Oop, 1 second. I have to update an attendance because Katie has arrived.
And we're giving the last spot on it.
Katie, did you email me saying you weren't going to be in class and now you are in class, or you never emailed me at all?
No, I didn't email you at all.
Okay, that must be for science 10. Katie,
Katie James?
hmm?
Katie James?
Katie Watt, I think.
Oh, Kate.
Kate Watt. Oh,
I'm gonna be selected.
I didn't.
There's always that.
There's always that as well. I should double check.
So easy to watch it on the corner.
Now, that looks good. Where's the... That... Oh, is that a 9 at the end? 4.9? Sorry, I have my wrong glasses on. Who's here?
On which number?
The
last
one that's
answer.
in brackets. Is it 4.1 or 4.9?
That's 4.9.
Okay. And that one there. Where's the K? Okay. Now there is a difference. I've got a lot of 5.0s and 4.9s. Is there a rounding error? Was it 4.92 or 4.95? 4.97. So if it was 4.97, don't cut it off, round up. If you really did get 4.92. So this one doesn't require the same assumption we made last day. We can just take it, oh, this is the value. So a pH is always the equilibrium value because it has to come to equilibrium before you can measure that, because at the initial it's always 0. So that means we can say, oh, this is 0.01995. Which means we know that we added that. Which means we know we minused it. And that would be 0.8. So for this particular one, like our ice tables from before, you didn't need to have an X value, you just need to calculate them all in because you're asked to calculate the K value. If you're asked to calculate the K value, you have to have been given everything. There will be no X. Well done. Despite coming late, you are sharp. Everybody got there actually quite quickly. I want to go back to last days for a second. I want to make sure nobody's still writing something down off the board right here. People still writing?
Yeah, you
Okay,
can
we'll wait.
a minute.
I can wait for a minute.
Can you go back up to the top of the Excel for that?
Oh, that's just a table.
Get a charger.
Well, while you're doing that, I'm going to do my new favorite activity.
No, okay. Get a charger.
I don't want to plug it in. No, no, you keep working. I don't want to stay.
I finished.
Oh, okay.
Huh? Mine's at 4.
Excellent. That's not sounding so. Is this full? Nope.
You got a charger?
pH values, always equilibrium values. Concentrations given of the solution, always initial values because you make up a solution by calculating it and then making it that concentration. And so we always calculate based on whatever acid it is. And then from there you can calculate the Ka. And that's how you'd figure out the Ka of any acid. You just make the pH. That's okay. I wasn't going to flip just yet. I was going to ask. I just want to go back to last days where we did the greatest math action that you could ever possibly do.
Will you jump up and down again for us? Bringing the whole excitement back?
I'll play the little sound file. Ooh. You're right, though. It didn't have the proper musical accompaniment.
You gotta go for it. Get some confetti.
No. I used to play this for it until I got those sound clips. What? Why are you installing it? I already have it installed. Shut up.
Do you go to the very top real quickly for like 2 seconds?
1 1,000, 2 1,000. They're also on the board all around you. Like everybody got it right. Let me know when you're good, though.
Mr. Newfield,
Question?
you got an extra charger?
For what kind of computer?
USB Type-C.
No. Oh, no. Someone left the charger back, and I was like, but they took it. I have a ThinkPad charger. I should get a USB now that it's becoming more universal. That would be a handy thing for over there. Glue it into the wall so people can't take it, but then there'd be a universal charging thing. Yeah. Josh, you good?
Yeah, I'm good.
Okay. So, last day. We never actually finished this off. I just got to the point where I showed you this, where I'm not going to jump up and down, but it does need a little bit more gravitas. There we go. If you don't write that, it will be assumed to be a mistake. So you can't just go from here to there without writing that. You do have to write it. Because that let us know that you did it on purpose. You might be saying, but Mr. Neufeld, if I do that, obviously I did it on purpose. Students drop calculations all the time by mistake. So I don't actually know. If you do that, you're allowed to. So you can turn this from something that requires a quadratic to something that doesn't require a quadratic, and then just solve it. Yes?
Do you have paper copies?
Yeah, they should be up here somewhere. Or at the back. Yeah, they're right here.
I'm just trying to look at the stream that got to my previous page and your stream's on Spotify now.
My stream's what?
Looking at your Spotify right now.
Oh dear. Hold it. That means this thing's set on the wrong camera the whole time. That's irritating. Thank you. Now it's fixed. Okay, once you do that, you just solve for it.
Can you scroll? So I went to the stream to show you at the top of the page. And you can go up.
Oh, I see.
And then eventually I'll see it. And then
I
you can go back down.
1, 2, 3, 4.
And I can just pause it.
1, 2, 3. But it needs time to focus. I thought no, sometimes it won't focus. which is weird for a stream.
Here, I got it.
Oh, it's your
I
bit
got it.
rate. It's your bit rate on the screen.
Yeah,
I got it.
it needs time.
Thank you.
And it's weird how digital things, because of other reasons, will mimic analog problems.
I have another question.
Well,
Focusing is an analog program, bitstream, but it ends up being the same thing. Okay, everyone right now, just calculate the pH given that number. Yes.
Wait, why? What's the importance of writing like exactly that? Like, why is that?
See, look, I can look at the number.
What's the importance?
Yeah, like
No, can you
why?
like actually explain why that was?
Like, why is that like if we don't write that we lose marks? Why?
You took the, can you solve this equation?
not mathematicians, so we just
How?
remove the X.
I'm
You would have
moving
to log that.
0.15 like more times.
So you can take 1 point. I'm going to get rid of the times 10 to the minus 5 just to make the point. So, because I don't want to rewrite it. So you take it like this and you go 0.5 molar minus X is equal to X squared, right? And let's just pretend that that's 2 for ease of calculations. You go 2 times 0.5 is 1 minus 2X is equal to X squared, right? How do you solve for X? If you square root the both sides, then you have the square root of 1 minus 2X is equal to X. How does that help
You
you?
can move X squared to the
No,
other
just
side.
do x
And then
squared
you
plus
use,
2x minus 1.
quadratic for
Oh, okay, so you put that over.
Is that
So
what that
if you don't do that, you have, let me just pull that out. Then you put that over, and so you have minus X.
No, just put the others to the other side. Make it X squared.
X
Oh, okay,
X
so-
plus 1, X
Okay,
minus 1.
so if so I will go minus 1, plus 2X, plus 2X. What's the number on this side when I do that?
X squared
What?
0.
0 is equal to X squared
plus 2x.
plus 2X minus 1. What do you do now?
You factor it out.
No!
Why not?
Because that's how much work is this?
Not that
But
much
will it give
more.
you the same? If it gives you the same answer,
It will give you 2 answers.
then that's
Yeah,
better.
one will be.
There is no 2 answers. There's only 1 correct answer.
Exactly. Yeah.
Then you just take out the
But
negative
why you
ones,
do
you get
this?
a negative
Why you
one
do?
as an answer.
Stop. This is math, and it's weird math. We're not going to do that. Or bear with me here. We just say, let's pretend this doesn't exist. And then you solve for that. Now, which one of these is easier to solve for? Well, not a rhetorical question. Which one is easy to solve for? Yes, Tia?
Yeah, that one's like.
Yeah, no. And you're like, well, why? I explained this to Ms. Walensky. She wasn't aware we did this in science. It did break her a little bit, not as much as the calculus under a curve one did, but a little. It still pisses her off. The reason you can do this, what is 0.500 minus 0.000001? What does that equal to the correct number of sig figs?
0.5.
Yeah, 0.500.
No, how do you know it's 0. That very small number?
If we were in university, you would have a second step. To make that assumption, what you would do is you solve it, you get an answer, and then you would compare it to that. And if it was 5% of the value or lower, that's a reasonable assumption to make, and it's fine. It's within sig figs.
No, because they say, look at this, for X we got 0.0199.
Yeah. So sometime, well, there was no X in there to do it for.
But say we found X, and then if you put it in.
Yeah, and you put it in. So in chemistry 12, you'll never have an X that you can't do it for. In university, if this number turned out to be like, I don't know, 0.3, obviously you can't do that. And you would have to do it. You still actually wouldn't solve the quadratic even in university. What you then do is then you just take whatever value of X that you know that you got that you know is now wrong because you did that, and you go up here and you put in that wrong value for these X's. Well, you actually put it in here, and then you solve for that X, and you get a new number that's slightly closer to the original answer, and then you do it again until whatever sig figs it gets to what you want, and then you stop. That way, if you ever get complicated quadratics, you never. There's some quadratics you can't really solve that easily. Done.
That just goes against all that.
No, because math isn't real. It was just invented by a bunch of people, usually old white guys. Nobody trusts them. Did I explain last day how you calculate the area under a curve?
Yeah, you did.
Yeah. It's practical. It'll work to any reasonable amount of sig figs that you want, provided you have a microbalance. And you don't need all that weird calculus math. You can just stop now, go into chemistry or physics, and use like real math, which is geared at something. The reason this fundamentally works is because science deals with things that have truth values, and so there's an area of error. And if your calculations are in the error area, you don't need to worry about them because they're washed out by your instruments. There's too much error there for you to care about it. So you can get rid of it because it's in the error. And I think this drove Eric almost insane last class because he says, well, you're saying x is 0, but it's not 0. No, we're saying 0.5 minus x is still 0.5. We're still solving for x. It's just that when it's minus from a really big number, the big number just remains. It's 0.499999999, so who cares?
Can you show us the way you do it at university if that number was 0.3?
Oh, if it came out to 0.3?
Yeah.
Then I'd go back here and I go, oh. I usually would have to make a formal set. 0.3 divided by 0.5 times 100% equals, and you get some amount of percent that's greater than 5%. So then I go back in here and I go 0.3. And then I'd resolve for x. And I get a new number. And then let's say that new number is, I don't know,
How do you know, like,
0.285. Pardon?
At what point do you know that you've got the right number?
Oh, how many sig figs do I need to go to? So let's say I need to go to 2 sig figs. And say the next number is 0.28. I'm going to 2 sig figs. I go in, I put 0.2 in there, and then I get 0.283. And then I take that number, I put it in there, I go 0.2821, and then I go, oh, I only need 2 sig figs, and this number is now staying the same. That's with 0.28.
Okay.
Yeah. You never have to solve for the quadratic.
But then you have to like solve 100 times instead of just doing one quadratic.
It's like 2 buttons on your calculator, it does it for you.
Yeah, but like
And you can just write it.
solving a quadratic is still possible.
No.
Yeah.
That's what math teachers want you to believe. They're not real people.
But we can choose like in a test, right?
Oh no, you're not allowed to use a quadratic.
What?
If you use a quadratic and you get the math correct, yes, it's acceptable. In my 24 years of teaching Chemistry 12, on the final exam, every time someone has used a quadratic, they've gotten it wrong.
Why?
I don't know.
What if we get it right? Extra.
That's great.
Under 10%.
But what, they either pick the wrong one and they write a paragraph explaining how concentrations can't be negative, so there's something wrong with the question, or they just do it incorrectly. This is just so easy. You just keep going. And often, sometimes they think they made a mistake, and so they redo it in a weird way. Just know you can do that. And this is a regular, this is not like a weird thing for Chemistry 12. You're allowed to do this. This is a real math thing. It's just math in the real world, not math in weird, Mr. Wardrop world.
How wardrobe world is a quote, not
Yeah. Okay? What did you get for the pH? Or are people, how many of you have done the pH? Finish that off. Get the pH, make sure you can use your calculators. Solve. What does x equal? No, right here, this one. Did you get it last day and I just didn't write it down?
I think so, yeah.
Because I thought the bell rang and we hadn't gotten it. What is the pH then?
2.52.
3.52?
Oh, I got 2.5.
2.52?
Yeah.
Oh yeah, I think you had to show me before you left the room. Yeah, 2.52. Okay, that means let's do that one. Not that one. We just did that one. That one. And toolkit, group maker, Groups of 2. Ashley, you can join any group you like. Find your partners. But before you go, once you have solved for the pH, POH, H+, all those values that it asked you for, show me. And then after, for the rest of this block is Hebden, quiz study, catch-up time, work. So, okay, so you get it done, show it to me, you'll be good to go. Okay, and we're just on the next question in the notes. Find your people, and then I'll put it back up as well. Grab your people.
Wait, Nick, can we go here? You guys go in there.
Let's go to the space. This one. Alright.
Everybody got the groups? Josh, you know who you're with? Okay. Just go from there. Calculate the concentration OH minus POH and pH of 0.1 molar NH3. Ooh, a 10 using the ruler.
Are we doing it as a
No, if we do an acid formula, we're not going to be able to get anything. Because it's a strong base and we're calculating for POH, OH, and H+.
Yes.
And it's a strong base too, so if we used it as an acid, we wouldn't be able to get anything. Let me cook.
I'll let you cook. I'm not going to say anything. I like how "let me cook" has become a phrase. It's very chemistry. Samuel's not here. We got everyone.
Is here. Let me cook.
You burnt it.
You did burn it.
Everyone else. Let me cook. I'm seeing if I get this right. Off of an intuition. I don't care. Off of intuition.
We got. Yeah, we need.
This is the base.
POH.
So,
It's an acid. I'm doing it this way. I'll do it the other way after.
Doing it my way. That's like a song.
Did you write down the...
It goes to completion. Well, then that gets us
So I think this is...
H2O.
Alright, we want to get on
next
this.
log.
this one?
Yeah.
So if we get any out of 3.
Wouldn't it be equal to KP?
Which do you think?
Base. And H2
So KP. That's K and
goes to completion.
We can just do this shit.
Yeah.
Actually,
This is a base.
It would work.
Oh, it is.
I now understand what we're supposed to do.
and we have the KA, and to go from KA...
You have a lot of formulas on a previous page, like a lot. Like go back a couple pages.
It goes to
You have a big
completion,
square.
so
Actually,
A bunch of formulas beside the square, and everything.
it goes to completion. Completion.
I'll show you down
You were
this.
completion. There's no equilibrium.
Just like that.
yeah, I've seen that.
How do you go from KA to KB again?
You.
Initially.
I don't think you do, it's just like the same, right?
No,
No.
it's KB's base.
It's kind of opposite.
It's
I think they add to something.
Did we do this thing?
Yeah.
Wait.
So that this is the KB version, isn't it?
NH3 is acting as a base. So right
Here.
now you're,
Is this it?
that's Ka times Kb,
Yeah.
okay, yeah. So we know Ka, we know this, so this is 1.
Yeah. Minus x, you can't get a negative concentration.
5.6.
But that's a plus x plus
That is x.
And then the other one is
And then we have x.
That's what I'm doing.
First we can just multiply that over, and the one doesn't matter anymore, so that's x squared is equal to that's a
Is
K.
this stable?
For this one, like, I didn't think we needed to present yourself for H.
And then
Yeah, you've given these. What are you trying to solve for? What are the three things you have to
So it
solve?
doesn't act as a passive.
And where does
The
it go?
arrow's in the wrong direction.
10 times the negative 10.
And so what value is it?
It doesn't go in that direction. Check here. But we use it as it's a strong base. It doesn't act as an passive.
Is that a W equation? What kind of equation? Is it a base or
Get
an
rid of the x
So,
value.
okay.
No, fine, so we should yeah,
how many
x.
fixed? Like, what did the question?
Do you have your notes here? Because remember, like, 2 pages back is a big square, all these calculations plus one of them.
I get that.
So I was doing it the correct way.
There you go, yeah.
In the middle of the way. Because the way I do it,
Oh, this is right.
and this way I wouldn't get any answers.
You know that, right?
Let's just write
Good
it
table.
as oh, H.
This is pretty small.
So. There's no, well, and here's why it's wrong. You found any straight acids. You can never back it. You wanna find it on place, then that's the next step. You know what? Good eye.
Negative log of that.
How are you doing? It seemed to have started off well. Now you've got KA written there, but then you, oh, good, you switched to KB. Perfect. What's KW?
KW over K.
Hold it. Why do you have 5.6 times 10 minus 10?
Yeah.
Is this, oh, you don't have to erase it. Was this a restatement of that question, or were you calculating something?
Right, it'd just be KW over
Yo.
Yeah. Okay, so, right that.
Hold it.
Oh, actually, 2 sequence and it's
You have KB equals a formula,
I'm lost.
and then you just have a minus
And
x.
then-
Where's that come from?
14
That's the change.
Or you cover the.
Yeah. And why is 5.6 times 7 minus 10? Write in your values for equilibrium.
6.
Yeah. Because you didn't finish your table,
But that's
now
one.
you're writing different thing. Finish your table. And you have a whole nother formula for calculating that. That's not the only thing that's like that.
Where you get stuff?
I'm just gonna continue doing it this way.
Oh, that's just because one.
You have a table of KAs, and you know what KW is.
What? How do I know what to do?
Because that's a K. So if you put that over,
Oh, okay, sure.
you get KB. Right? No, but if you find the KB, you can find the
Make
rest.
your sister
Oh.
see. Can I steal it first?
It's a 1 to 1.
That's what we meant.
1 by 1.
Let me check. I think you're good. I might quibble about a decimal place, but 2.37, 11.63. Yeah, you're really good.
This is right?
That's KB.
This line you got, right? KB, so Do you know how 1 times 10 to the negative 15 is equal to Ka times Kb? Divide both sides by Ka, you get 1 times 10 to the negative 14 Ka is equal to Kb. Plug that in for Kb. You get this. We got the Ka from the
this ratio that we have.
and then you just solve
Where do
it.
you get the forces from? The 1 times.
Oh, that's just Kw.
I'm doing
We
it.
did that in one.
Okay.
Because you can't do it this way.
Yeah.
So you can't do it.
And then you
This way you
solve
can't.
this
I-
is
Give her the
I feel like, why do you have an HQ in there? Pass away. Because I know what you're using. And I let you cook for a long time, but at some point you're gonna blow up the, RV.
oven.
No, the RV, because you're cooking meth.
But,
I don't.
Because the math you're doing is amazing. I don't know, but what you've done is you've found it here, right?
Right?
I just went straight there.
Yeah.
I didn't even look for an
the same thing.
And I was planning on doing this.
Yeah. Yeah. But the key is there it's an acid. You want to find it where it's a base. It can't be an acid. It can't go backwards. So you want to use this equation. You do want to go the other way. Because you're just going to just for plus so it's minus. But that'll put you on a much better track.
This is POH.
Yes, look. Everything's there.
initial concentration.
Are you Wednesday? Quiz?
Thursday.
Thursday.
Yeah.
What do you do? What do you do for you? What do you do with it? That's the Oh shit, okay. So wait, no, minus log is minus log. This minus log equals POH.
Negative. I think that's just calculated. Like the 1 point. Yeah. You got 1.79 from this.
And then take away 14 minus 2.27.
Now that everybody's on it, I can go.
Like I did the square root like for the whole thing. And then I got that. I divided it. No, that should work too what you did. So that's why let me do what you did. 1 times 3. It's like over 5.6 times 10 to this one, right?
No, like, you don't make this whole thing is.
Oh, yeah.
Oh, yeah, but that's.
Yo, we did that.
One.
I got a
Because mine,
Can you check it? Let us know if it
is like over.
I like the picture, man.
Not just
So most extremely good, so I'm here on the track. I don't know. 2 point, what is the, 2.37, perfect. And your X value, awesome. Yes.
That's
Yeah.
That's
Oh, the right amount of sig figs should be 2. So in the end, you're gonna wanna go concentration OH minus equals, and then the amount to 2 sig figs. Most likely, you're gonna mark the pH and pH ones, and those are both the 2 sig figs, since those are good. Only the hydroxide one. But yeah. And you successfully found out the KB and realized what
So
KB.
we're always given the K's.
Oh yeah,
Always
and then you take the
But
square root of that.
we always have to solve.
And then you
it.
should
Always have to solve for
you
KB.
should get
That was the whole point of this question, was everybody to go, ah. The other class, immediately, it was weird. Everybody wrote that equation, and then they all wrote a KA and started solving it with 5.6 times 10 or whatever. It was like, boom.
I got a 4.
And they also needed a little thing. But,
What's that?
like them, you caught on fairly quickly.
When was this? Was this from last year? No.
Wait, Mr. Defoe,
Mm-hmm.
didn't you say something about like the eggs like on the bottom, you can just sell it this?
I don't think I was gonna
Yeah,
get
you
it.
can.
Yes, yes you can.
Wow.
So you can go let this minus X equals this. Yeah.
Because everybody like all
Well, 4.2
everybody's
cents
on
is
board
negative.
like on email. How do they get it's stressful.
Sonia, one thing just to watch out for, because I saw a few other people do it, and I remember it from Equilibrium, is that you stop there and then you jump to doing your equation. Always make sure you just go through. Because if you stop there and you try and do it in your head, it's very easy to pick that out without remembering to do that. And if you just always make sure like 0 plus x is x, 0 plus x is x, then you'll probably start in the right path and you won't just make that mistake.
K is 5.
Because if it wasn't for that, it was perfect.
Is that KB?
Ah.
Then K is 1.
You're saying KB is 1.0 times 10 to the negative 4. But that's equal to x squared. So you times this by 1.0 to get this, right?
Glenn, what KB value did you get?
We got 1.7857.
7 times 10 to the.
Times 10 to the negative 5.
Perfect.
Okay, I'm just gonna wait for them to do it.
What? No, I'm stopping you.
Just like derive it from them then.
Because you're on the right track. Because all of yours are on the right track. And so let me just check. Let's do another equals 1.0. That's perfect. And you get that. But you've made it equal to this.
Quick left.
Yeah, which is where I was confused because I don't
Why
know
did
where
this- why did
that
I-
was coming from.
Ah,
You got the KB, but why do you equal it to x
you
squared?
have
And then that would be on page
Sorry?
The
Why do you equal
KB
the KB to x squared?
Oh,
right? So you have a
Because
KA.
we let
And where's
1.0
the
times
x
x equal 1.0.
right.
Oh, okay. This is just x times x.
This is, so you have
Yep.
and you know this relationship from the big square and with it.
So it would be the opposite.
So yeah, well, you know what this is,
So,
1.0 times
yeah.
14. You divide it by that and you can calculate the K. So you always are given the KAs, but you always have to calculate the KBs. So who's the point?
And then if you're trying to find pH, and this would be Ka because it comes outside.
Literally start with that x squared over.
Oh, I wasn't checking this as I was going around. When you made this, did you write on your work that statement? Double check. You do have to have it.
Yeah, we have.
If you have it on your work, you're good. If you didn't write it, it's hard to tell.
Wait, Mr. Newfield, isn't it the same thing if you did a square root of 1.785 times 10 to the negative 5 equals x?
Yes, I just didn't want to. I wanted to show here that I took out the x, so I'm keeping the 1. But yeah, it's anything divided by 1 is itself. And just especially if anybody isn't here, there's one person, Samuel, I think, so that he sees later. Oh, that's what they're doing.
Just looking at that. Just like Mr. Newfield,
Mm-hmm.
on the next question on page 13, for like, there's like a part that says calculate the POH, and it just says over bracket 3, 0, 8.
Oh, the 3, 0, 8 is that so that while you're doing it, you could know if you got the right answer. It has those digits in it, but you don't know if it's 3.08, 3.80, 8.03. Like, but if you get those 3 numbers, you know you're right.
Okay, so you should do that for all the questions on the test.
It would give a feeling of confidence, but then if you never got them,
And then you go back again.
yeah.
No.
Well, as a teacher, if you could check your answer, it would help if you could redo it and get the right answer. But there's always a core of students who will then, knowing it's wrong, erase all of their work so I don't see it. And then they get 0 instead of 4.5 out of 5 because they made one little mistake they can't see. Curses. Curses. So the rest of the class is yours to study. Hebden. I may ask to see your Hebden soon, just to give you a heads up.
Do you still have any Hebden books?
Yeah, they're all up here.
I thought they were like.
They've been sitting up here for. What do we got? We got Lavina. This has been here for a long time. We've got Sam and Luca.
Make myself
Oh my god.
practice
The one where they don't bring their pencil. That's really awkward. That's how it goes.
Okay, since we are now it's working.